Okay, so let's go ahead and work this example of the train going through the station here. What we're told is we have a train that's initially going 22 meters per second. It starts slowing down when it enters the station with an acceleration of deceleration of 0.15 meters per second squared. And the length of the station is 210 meters. And we want to know how fast is the train going when it exits the station. Okay? So what we've done is drawn a picture here. We have the train, its initial velocity, 22 meters per second. The station is 210 meters long. And while on the station here, the acceleration is negative because it's slowing down. Okay? So it's a negative acceleration, 0.15 meters per second squared. So in other words, what I've drawn is positive velocity, negative acceleration. Okay, so it's slowing down. And we want to know how fast the train is going when it exits. So let's go ahead and write down the things that we know. So we know the following. We know the displacement. It's 210 meters. Okay. We know, it should be the x acceleration. We know the acceleration. And we know the initial velocity. Okay. We want the final velocity. Okay. So now this is that time again where we go through our list of equations and we try to find the equation that best suits this set of variables. And the equation that best suits this series of variables is this one. The x final squared equals the initial velocity squared plus 2 times the acceleration times the displacement. And again, the displacement is x final minus x initial. Okay? So we can go ahead and start plugging these numbers in to this equation. And when we do that, we see that Vx final squared, that's what we're trying to solve, equals V initial squared, which is 22, plus 2 times the acceleration. Acceleration is negative 0.15, times the displacement, which is 210 meters. Okay? So when we do that, when you do this calculation on your calculator here, so we do that, we do 22 squared then we do this operation plus 2 times negative 0.15 times 210. We get the number 421, but that's the final squared. So we have to take the square root of that number. And when we do that, we get our answer. Our answer for the final velocity when the train exits the station is 20.5 meters per second. Okay? So there's our answer for part A, 20.5 meters per second. Okay, in part B, we want to know what the full stopping distance of the train is. If it continues with this acceleration or this deceleration for the entire time. Okay? So let's go ahead and draw that. Let's erase some of this here because we're going to get rid of that anyway. Okay? So let's draw that situation on here. So everything's still the same. We have our train initially going into the station, but our final situation is our train somewhere way out here, and its final velocity is what? Well, it's stopped, so its final velocity is 0. Okay? And we want to know what the full stopping distance is, okay? We want to know what the final position of this train is when it does finally stop. So we're no longer concerned with what's happening at the exit of the tunnel. Okay? We're just concerned with this distance from here to here. Okay? So what do we know then? Well, we know the final position. Sorry, we know the initial position, but we don't know the final position. So this is something we're going to want to find out. Okay? We know the acceleration, it's still this. We know what the initial velocity is. Okay? That's this. And we now know what the final velocity is. So the set of variables we know is still similar to part A. So this is part B now. It's similar, but it's slightly different. We know acceleration, initial velocity, and final velocity this time. But what we want is the displacement, delta x, or the final position minus the initial position. That will be our answer. Okay? That'll give us the stopping distance of the train. Okay? So the set of variables that we're concerned with here is exactly the same as what we had in part A. So therefore, we're going to use the exact same equation here to solve the problem. Okay? And that's this one. Okay, so let's plug these numbers in here. Vx final is 0. The train comes to a stop. Vx initial is 22. That's the same as in part A. The acceleration is the same, negative 0.15. Except this time, we want to solve for delta x. Okay? So this becomes just an algebra problem. We just need to solve for delta x here. Okay? And so after you do that algebra, 22 squared, and then you divide by this other stuff here, the answer you get is a stopping distance, delta x, of 1610 meters. Okay? Or in terms of kilometers, that's 1.61 kilometers, or about a mile. So it takes a while for this train to really slow down. Okay?